Okay. Okay, I think most of students are attending this class. So don't waste our time, and we start our course. Let me share my slide first. Uh, okay, because this course is going online, so I don't think we will meet each other in the future. So would you please turn on the camera? So let me see all students in this classroom. Okay, is this okay for you? Yeah. Very good. Very good. Yep. Okay. Just show me a little bit. That's okay. I just want to know how many students in this classroom. Okay. As you may know, our university asked us to teach course online from September to October 1st or 2nd. I'm not sure. However, even when we came back to campus, because the number of students in this classroom is more than 80, so more than 80. So we are not allowed to uh, we are not allowed to teach this course face to face. So suppose this course will continue online, will be a online course continually at the end of this class. Yeah, at the end of this semester. So that's it. Okay, okay. Thank you so much. And then you can turn off your camera. Yeah, thank you. Also, I will turn off my camera. That will be more comfortable to me. Okay. But I think the sound is okay. So there's no supposedly there's no problem. Uh, you guys are okay with this. Because okay, let me share my slide first. Okay, can you see my slide now? Yeah, I think it is full screen right now, right? My slide is full screen. How to? Wait a minute. I need to find out where can show the children. How to show? I'm not really familiar with. You guys prefer Cisco WebEx or Google Meet? I prefer Google Meet. I don't like Cisco WebEx. It's not really. It's hard to use. I cannot see the children my screen. How to show? Anyway, I can I cannot find the children right now. However, I will continue the course. If you have any question or any problem, because I cannot see the children. If you have any question, please just turn on your microphone, and then just speak to me. Okay. Okay. Because this time there are about maybe 10 to 15 students. They are new in this classroom. So I will very briefly to introduce this course about maybe 5 to 10 minutes. For those students you had attend this classroom last week, you just pay attention. Okay. Uh, Okay, the course is data structure, and I'm the instructor, Fan Xun Zhen, and then you can find my email. Suppose the new student in this classroom, they all write me a email last week, and I think there is none very important. And the course description and the object is this course is this course emphasis data structure and the development and analysis of their associated algorithms. So in the middle of this course, I will teach you some maybe sorting algorithm and yeah, something like that. And then some specific data structure, for example, array, stacks, queues, linked list, trace, class, sorting, and hashing will be taught in this course. And the object is to understand the basic data structures and also apply this data structure. And for example, if you have to complete a task, and then there's no rule to implement your program, and then you will consider and then you will think about it. What kind of data structure should I use? Maybe you will use maybe array, maybe matrix, something like that. Okay. And also in data structure, there is also important issue. It's to measure and calculate the complexity of this data structure. And I will introduce in this week. And also implement data structure in C++ language. And here is the progress description. I think it is not different to other class, so I will not spend too much time on this. However, you should know two there. However, you should know there are two tests for this course. Okay, the midterm should be the the midterm should be in week 9, not week 8. I think this is wrong. And the 18 weeks is the final exam. So, however, I will try to accelerate this class. I hope I can. I hope I can finish this course about maybe 16 weeks, and then we can take the final exam at 17 weeks. Yeah, that's it. And here is the textbook, just like show in the nothing special. Okay. Uh, okay. Supposedly, supposedly you should buy the textbook. However, I'm not insist everyone should buy the textbook. If you are interested, if you are interested if you are interested in this course, maybe you can buy a textbook. Okay, that's it. Also, I will not give I will not provide my slide to all students. However, just like I said, this course will continue online. So you guys in this class, you can, for example, you can just make screenshot by your own self so that have you can have my slide. Yeah, I think I think that is not a really problem for learning. Yeah. Okay. Here's the I think maybe here is the most thing the new students want to know, and here's the grading policy. Uh, okay, first there will be at least two and at most four program assignments, and you should implement your program in device C++ platform. Uh, until now, I insist you guys should use device C++ to implement your program assignments. However, just like I say, if my TA they are they are agree to use maybe other IDE environment so that you can use other uh, platform. I will I will assign this. Anyway, anyway, that's it. And the grading terms, there are only three grading terms. The first one is midterm exam. It uh, it is allocated about 35 percentage about your semester grade. And the midterm and the term exam, which means as well as final exam, it also takes about 35 percentage. And the assignments, the assignments has 30 percentage. Okay, so for example, if I assign two program assignments, so each one will be 50, 15 percentage of your semester grades. Okay, the last two points you should read it carefully. I insist the students cannot be absent more than 4 times. So, okay, some student ask me, can I let can the teacher will the teacher let them know their how many times they are absent. I don't think I need to do this matter. However, if you reach 4 times absent, I will let you know you're going to fail. So I will remind you if you absent one more time and then you will fail this class. Please read it carefully. I'm not assign any percentage about the show up. However, I insist you should attend this course. This just like I say, you should respect to the teacher, and I respect all of the students in this classroom. Okay, the second point is, yeah, you can ask when I ask you to deliver your program assignment. You should not copy paste your college, your classmates' homework. I will ask my TA to check this very carefully. If I have any question about two assignments from two students, I will let me see. Okay, I will ask you to come to see me, and then explain why why your homework why your assignments are so similar. Okay, okay, that's it. Okay, here are some important things the students should know. Uh, you need to have some basic computer concept and then also the C++ programming skill. And okay, this course is focused on data structure, not English conversation. But however, I will try my best to deliver necessary knowledge to all of you in English. So just like you see. Okay. Wait. Uh. Let me see. Just like you see. Just like you see. I will not supposedly I will not speak any Chinese in this classroom. However, if there is any question that I cannot explain in English, I will try to explain it more clearly in Chinese. Okay, that's it. And here's the TA. TA is Kevin. He is not in this classroom. However, supposedly you don't need to you don't need to find you don't need to see the TA. Only if only if you want to deliver your assignment to him. Yeah. And okay. Uh, okay, I think this is not a important issue because all students in this classroom should be enrolled in the cross system, right? Right? Uh, does anyone who in this classroom but you are not in uh, cross system? Hello? Anyone? 有没有人在这堂课里面，但是还不在选课系统名单里面的？应该都有了哈。老师的认知是这样，所以这个应该不是一个问题。OK，嗯，OK，that's I think that's it. Does anyone has any question? Last week, some students leave some message for to me, and the first one is the course slide. Just like I said, I will not provide the slide to you. However, you can screenshot by your own self, and then you can have the slide. And the other one is some student ask about uh, uh, when ask about the grade of the assignment. You don't worry about this. If you have any concern about your grade on the assignment, and I will provide an opportunity, and then you can go check your homework, go check your program assignment with TA, so that you can maybe you can the grade can be modified only in 1 week. Okay, if uh, for example, if I make a policy, you all students should deliver all students should deliver their assignment maybe on October 10. Okay, and I will provide you a grade at that time. And after 1 week, you can check your homework, check your program with TA, so that maybe some misunderstanding and can be solved. Okay, I think I think you can understand what I'm talking about. Is there any question? Let me check. Let me see the chat room again. Hello. If you have any question, you can turn on your microphone and then speak to me right now. Otherwise, I will continue this course. I like. Oh. Okay. I still cannot find a chat room. No matter what, I don't want to waste time on this. Okay. So okay, can you see my slide now? Hello? Okay. I see some thumb up. However, it seems that some students leave message in the chat room. I cannot see the chat room, so it will be better if you have any question, you can speak to me right now. Hello? I cannot. I'm really not familiar with WebEx. How to see? Hello? Is someone's ah ah I s- okay, I can see now. Uh, if you want to see the children, you should move your pointer. You should move your mouse to the top of the screen, and then you can see a option. Okay, that's teacher. Can you on put on what? Put what? Uh, I will not put. I will not provide my slide to you. So don't ask me again. And then if you really want if you really want to have the my slide, and then you can screenshot when I'm teaching. Okay, I think that is not a problem. Okay. Okay. I will start to teach right now. Okay. So in chapter one, okay. In chapter one is the basic concept. So here is the outline. Uh, the first one is what exactly data structure is, and the second one is system life cycle, and the third is data abstraction and encapsulation, and the algorithm specification, performance analysis, and measurement. Okay. Okay. So first, we should introduce what exactly data structure is. Uh, Here you can see in your first year, you have learned program, right? It's called what? 程式语言, right? And also in this semester, here is your second year. You are second year student, college student, right? So you will learn data structure, and then maybe in your third year or the fourth year, I'm not sure, you will learn algorithm. So um, in last year, in your first year, you had to learn program, but I don't think you really focus on data structure. and also the algorithm. Okay, so so the second year is to learn what is data structure and what kind of data structure is more efficient. And so uh, the second issue is how to complete programs rapidly. Um, I'm not sure. Last time, uh, I, I I remember some students told me in the first semester you learn C and then you learn Java, right? I remember. Okay. Uh, However, there are programming language. Um, Data structure can be implemented in any kind of programming language. So last time, one of student asked me he want to change to my class only because he preferred to use C++ programming language. But however, I reject him. I'm not sure he is in this class or not. And so how to complete programs rapidly and fastly? Should we use a supercomputer? Just like in recent years, AI, I think almost everyone in this class knows AI is popular, is famous right now. Just like GPU is used maybe everywhere. So should we increase the computing power for of the PC or of the computation node? Actually, as you may know, there is have you ever heard Moore's law? MORE or MORE? I'm not sure. Have you ever heard this law? Okay. The Moore's law is a famous is a famous what? Famous law. Okay. Okay. Uh, Moore's law describes every 2 years the number of transistor, you know, transistor transistor 中文 means 电晶体, okay? And uh, in Moore's law, every 2 years, the number of transistors on an integrated circuit, which means which as well as IC, will be double, will be twice. Right? So it is a very famous law. Maybe start from 1960 68 or 65. I'm not sure. The law is famous about maybe 40 or 50 years. However, however, the limitation of hardware is not is not easy to break through to overcome. So we should the other scholars they focus on software, they focus on data structure. So should we use a good algorithm or maybe an appropriate data structure is more important? Uh, I'm not sure. Okay, and then we just see in this figure, for example, there are two equations. Uh, Okay, there are two equations. The first one is 2 power of n, and the other one is n cube. So what kind of which complexity is higher? So just you can see we can start maybe for example maybe n equals to 8. So 2 power of 8 is how much? 122, 128, right? I'm not sure, right? Yeah, 128. And also, the a cube is equal to maybe how much? I'm not sure. Equal to 64 multiplies 8, right? However, when the n increase, maybe to 12, even to 15, the 2 power of n will be increased very, very rapidly. So we call it as an exponential equation, right? So, okay, I think that's it. So, you, um, what I want to say is, it is supposedly it is more important to to design a good data structure, to design a good algorithm. It will be better than you design a better, more powerful computing hardware. Okay, and that's it. So, summary: the data structure is the way to present data, and the algorithm is the way to process data, which is different. For example, if we, I'm not sure what kind of algorithm you have learned. Can anyone tell me, can you say a algorithm you know? Uh, how to say? Uh, can you make an example for an algorithm? Binary search. Okay, good. Binary search. Okay, binary search. Quick sort. Okay, you learn sorting. I'm not sure. Okay, you learn sorting. Okay. Maybe binary sorting algorithm. Yeah. Okay, sorting can be regarded as an algorithm. Okay. For example, maybe you expect to implement binary search in a program, and you should consider what kind of data structure you should use. Maybe you will use array, or maybe you will use pointer. I'm not sure what kind of data structure you will use. And so data structure is the way to present data, and the algorithm is the way to process data. And the programming language depends on what kind of programming language you like. Okay. So the second one is system life cycle. Okay, what is system life cycle? Supposedly this should be this issue should be discussed very carefully, very sophisticated in another course. I'm not sure in CSI we will take this course or not. There is a course. There is a course named uh, system analysis. Have you ever heard this? System analysis. Okay. Suppose if you are going, if after graduate, if you want to become a software engineer, you must learn system analysis and system design. When you take the course of system analysis, you will learn very clearly about what is system life cycle. Okay, so uh, uh, the textbook says the good programmers regard large-scale computer programs as systems that contain complex interacting parts. And that is not really important. So as a system, the programs undergo a development process called the system life cycle, including 5 phases. The 5 phase is more important here. Okay, here's the 5 phase. The first one is requirement, and the second one is analysis, and the design, refinement, and the coding. And the last one is verification. Okay, this is also similar to algorithm. When we design an algorithm, first we should observation. Okay, I try my best. Okay, the first one we should observation. The observation means you should observe what kind of problem you want to solve, and then for example, okay, and the second one is analysis. Yeah. Okay, you should analysis about uh, what kind of algorithm you should design. Okay, and then design. And then the fourth is verification. Okay. Okay. This is usually used in algorithm. Okay. And here is the system lifecycle. I will introduce more clearly later. So in the first one, system lifecycle requirements. So you should think about it. What kind of requirement you are going to solve, and the second one is more interesting. Is analysis. Analysis is okay. Analysis. Just analysis. And they can be they can be divided into two major kinds. The first one is bottom up, and the second one is top down. Bottom up means from the bottom to the top, right? And the top down means from what? From in system what? In system analysis. I apologize for my ugly writing. Okay. Waterfall. Top down is also called waterfall. Waterfall. Okay. Because it just looks like from the top to the bottom, right? You will not say waterfall is from bottom to up. That's incorrect. So how to analyze? Maybe for example, you have a big problem. Okay. Have you ever heard? Have you ever learned divide and conquer? Do you know divide and conquer? Hello. Have you ever heard divide? Oh yeah. Okay. Some students say yes. Divide and conquer means you just divide a big problem into be like this. The big problem is composed of two small problems. And then you can divide it first, and then you solve this problem. And then you solve this problem. And that's after that, you compose these two answers becomes the answer of the big problem. This is very traditional top-down approach. And then bottom up. Bottom up means you solve a lot of small problem, and then you compose it to a big problem. Okay. So in analysis, we should take we should consider first what kind of analysis approach you will use. You supposed to there is no correct answer for what kind of analysis methods you use. There is always a suitable analysis method. Some problem is more suitable for top-down approach, and some problems and some systems is more suitable for analysis. Just like I'm not sure you 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 found a very interesting status in our university. In our university, there are a lot of small systems, right? Have you ever think about this? No? There are a lot of systems in our university. And so even we have a portal, how to spell portal? Portal. I'm not sure how to spell portal. Piora. Okay. Piora. Okay. Portal. Suppose there is a portal, and then we can log in the portal, and then we can find all small systems in the portal, right? However, I think there are many systems which is not included in the portal. So our university is a very bottom up, I think, very bottom up university. I'm not sure. It's okay to say that or not. Okay. However, no. And the third one is design. When you system life cycle, when you design, you should consider about the data objects. The data objects means the abstract of data types. Just like C++ language, there are objects in the class, right? We use class to build objects. Okay. And operations. The operations including specification and the design of algorithms. I will introduce this part later. Okay. And the fourth is refinement and coding. And refinement and coding is you should choose representations for data objects, uh, just like here. Uh, the abstraction is also the representation, just like the skin, the surface. Okay, and and then write algorithms for each operation on data objects. Okay, the last one is verification. Verification is program proving, and then you just write a program and put a lot of input data and to validate verify to validate the program is correct. Also, uh, also testing and testing is for correctness and efficiency, and test a variety of input data. A variety of input data is used to confirm the correctness. So when you deliver your program assignments, I will ask my TA to put different kinds of input data to verify your program is correct. Uh, actually, uh, I don't think I will. I don't think I will. Uh, Yeah, yeah, okay. Efficiency will also focus because when I assigned when I assign an assignments, I will very clearly uh, to to make the policy and the rule. For example, I will insist you should use pointer or you should use pointer array to implement your program so that the efficiency can be confirmed. Because I restrict the data structure used in the program, so the efficiency can be confirmed. If I didn't restrict any data structure, so the efficiency cannot be confirmed. Okay, and the last one is debugging. And debugging, after you write a program, in CSIE, students always debug, right? So I think what is debugging, you can understand. Also, I also very interesting issue you mentioned right here. Here is a remove errors to achieve well-documented progress. I think most of students they don't care about the document. However, if you are going to be a soft engineer, you should learn how to write a, a well documented program. For example, just like every time you download some source code from the internet, you will see a very famous file. What is the file? Do you know? Do you know what I'm talking about? Yeah, README. Okay. Also, some students are very concentrate, very good. Okay. Yeah, README file. README file is used to uh, used to used to deliver the programmer idea and the concept to let the user knows how to use this program, and is there any issue or there something you should really care about. Yep. Okay, that's it. Okay, so okay, I think uh, be okay. Maybe it's time to take a break. Let's just take a break about 10 minutes. We will start our course at what time is now? At 410，OK？正义魔人去投诉我英语课用中文，哦哦，都讲中文也可以，就这个就有点超过了哦。这门课就是英语课。好了，我老师讲一下好了，就是线上课程上起来真的是，我相信应该不只有我老师，不止我一位老师有反映过这件事哦，就是我不知道其他老师会怎么互动就是线上课真的是很难互动啊。然后我又英语授课，更无聊了哦，无聊到极致啊，无聊到爆啊哦，反正就这样哦。那啊、OK，for those foreign students, I just murmur, nothing important. Okay, I'm not talking about the course. Okay, okay. 啊我再问一，我再问一下好了。所以这样上英文课，你们各位同学听得了、受得了吗？有没有人这样子？你们听得懂我在讲什么吗？It's okay. 哦，maybe try a line group for discussion. Discussion what? Okay, totally fine. Okay. Uh, okay. I will continue. Okay, right here. Okay. I know my English is not speaking is not very good. Okay, I'm not talking a very fluent uh, fluent fluent English speaking. However, I think most of things I talk you can understand. Suppose that's that's okay. I will be better. Maybe 看起来我明年也要教英文。好，I will be better, I think. Okay, so uh, let us continue the course. So while you evaluating judgment about the programs, uh, here are something you should concern. You should think about it. The first one is did you really meet the original specification? And just like the requirement, did you really the program really meets the requirement, and the program works correctly and well documented, just like I said, after you write down the program. So while I assign program assignments, I will ask you try your best to write some comment. Okay, to write some comment for your program. If you are unable to build a correct program, it's okay. You still need to try to leave some comments in the code so that the teacher can understand what you're doing, and why maybe I can tell you why you are fail. For example, maybe you use the wrong way to build a program. Okay, and then use functions to create logical units. The code is readable, and use storage efficiently. Use storage efficiently. 对， use storage efficiently is very it's also an important issue because in this chapter we will learn two kind of complexity. The first one is space complexity, and the other one is time complexity. I think most of you have heard time complexity, and the storage complexity it usually represents how many storage, how many memory do you allocate. Okay. And the last one is runtime acceptable. Okay, runtime acceptable also equals to it is similar to the time complexity for the execution time or running time. Okay. And okay, here's the role of data structure. Okay, the role of data structure. First of all, you will see the requirement, also the problem. What kind of problem do you want to solve? And the problem can be modeled as an abstract problem. The abstract problem is also right here. Design data object abstract of data types. So the abstract problems. For example, in the real problem, we want to solve the ordering problem. For example, all students, I ask all students to be ordered from the highest to the shortest. This is an ordering height problem. Also, the ranking score. The ranking score means everyone has a score. Okay, so from the highest score to the lowest, or yeah, and the abstract problem, sorting problem. Okay, but the ordering problem, and the ranking problem, as a abstract problem, it belongs to a sorting problem. Just like I said, from the highest maybe 190 to maybe 155. This is student's height. Just like a sorting problem. For example, the first student is 118, and then the second one is 100, maybe 116, and the third is maybe 119. And at that time, you need to you need to move this student from the first, right? You need to move the student from the first because he is the highest in this list. So the ordering height, the ranking score is also, if you are asking the abstract problem, it belongs to a sorting problem. And so we can use a lot of different algorithms to solve these two kinds of problems. Maybe you can use bubble solve, quick solve, merge solve, any. In this course, we will talk about maybe at least 4 or 5 sorting algorithms in following chapters. So first, you should model your problem as an abstract problem, to think about the real problem is what, and then try to find the algorithm to solve. And then used right here, used what kind of data structure, used what kind of data structure. And the data structure can be based on, maybe based on array, based on linked list, based on trees, and based on stack, something like that. What kind of data structure you want used is usually it's a very important issue if you are going to become a software engineer. And the last one is implement into a program. Okay, just like I say here. Okay, that is the role of data structure. So you can understand if you in your first year you learn programs, but you didn't care about what kind of data structure you used. And after you learn data structure, you can know you can learn what kind of data structure is more suitable for its problem, and then you can design algorithms in your third year. I think third year. I'm not sure. This is the second year, right? And this is the first year. Okay, and I think the problem and the abstract problem, this is belongs to under undergraduate, postgraduate, master students. Because master students, they are doing some research. They need to observe. They need to observe problems and to find some problems, and then consider to model it as an abstract problem, and then they can do their research. Okay. Okay. Here's the third data abstraction and encapsulation. Just like here, I will teach these two issues. Teach these two issues: abstract of data, and the simplification of algorithms. Okay. Uh, uh, Data encapsulation, or you can call it as information hiding, is the concealing of implementation details of a data object from the outside world. What means? It means what means? Um, uh, Maybe I will explain later. Okay? And then data abstraction is the separation between the specification of data object and its implementation. So in other words, in data abstraction, they don't really care about what kind of program you use. A data type is a collection of objects, and a set of operations act on those objects. For example, maybe int, char, or maybe you use class to build objects. Okay, and okay, the data type is the same. Okay, is the so you can see this slides made by myself. Okay, this is the same sentence with the previous slide. Okay, an abstract data type, which we abbreviate as ADT, is a data type that is organized in such a way that specification of the objects and the specification of the operations on the objects is separated from the representation of objects and the implementation of operations. So just like I say, in other words, a data type, an abstract data type, ADT, it is implementation independent, which means we just know we just know what it does, but it is not necessary to know how to do it. For example, I think most of students, in integer, just like I say, integer, char, maybe float, and maybe double. And I'm not really, maybe this is 2 bytes or 1 byte. Int is 1 byte, right? I'm not sure. I cannot remember. 4 bytes. Okay. Oh, right here. Okay. Because my memory is very short, so I always not to remember this kind of things. All right here. And according to the representation, maybe char is 1 byte, short is 2 bytes, int is 4 bytes, float is 4 bytes, and the double is 8 bytes. However, while you are using this kind of data types, you are not really care about it will allocate. When you use double, it will allocate memory with 4 bytes. However, while you are using float, you don't really care about how many bytes it is using, because this is the, just like I say, the abstract of data type. And the specification, including name of function, types of argument, type of results, description, what the function does, without implementation details. Yeah, that's data abstraction and encapsulation. So once again, I will summarize data type, data abstraction, data encapsulation, which means is concealing the implementation. You don't really care about. You just know what it does, but you don't know how it does. Just like I say right here. Okay. Here's the example 1.1 in the textbook. Can I know, does anyone already buy this book? Hello? Does anybody already buy this book? Hello? No? I think no. Okay, that's fine. Uh, uh, does anyone want to buy this book? if you want to buy this book, maybe you are considering to buy this book, considering buying this book. Can you please maybe raise your hand or give me a thumb up? Give me a thumb, okay? Hello? Uh, maybe only one. I want to buy. Okay.好，okay, right here, I will start to talk Chinese because this is maybe should maybe important issue should be uh clarified. 你们有要买书的人多不多啊？有需要，但因为这个班好像我也其实因为毕竟我是第一次在成大这边会有班代负责买书吗？Hello，这一班有班代在吗？应该有吧？对，乙班的课肯定全班都要修，所以哦，张玉伟，好，张玉伟你好，你是班代是吧？你有在负责帮忙买书吗？还是不走这一套的？
哎，老师好，
哎，是张玉伟
那个，
吗？
对对对对，因
也
为因为
是好
今年是因为疫情，然后现在还线上课，所以我们用的那个方案就是让大家自己上网买。
，OK，好，所以
对
目前为止的课程还没有帮任何一个老师的课程定书的，对吧？是这样的意思，对
对
吧？
对对对，
好，好，那大概也知道，而且我没有强制要求，所以不会有，应该会有一些人想买，但是订的数量可能不会太多，不如就让学生自己去买好了。哦，
好，
也是
那
可以的。
个老师可以给我们看一下那个书的名字什么的吗？就是我刚刚没有
哦，那
看到。
个在 OK 书的名字吗？好，
对对对，
那个在那个选课系统有，
全科系统有吗？
对，选课系统我有把书名就是对，看一下哦，那没好关掉了，看得到投影片吗？看得到吧？
有
OK，好，就这一本，书名在
，OK，
这跟那个选课系统里面的是一样的。I use this textbook. The textbook is the same I list in the cross system. So if you want to buy a textbook, you just buy this book. And I ask the 班代要怎么讲？I ask the the key person, the key person in this class, the uh, uh, because due to COVID-19, all courses are online, so the key person will not help students to buy the book. So if you expect to buy the textbook, you need to buy it by your own self. I think 呃呃请教一下，有没有人已经有查过了？这书是买得到吧？有没有人有没有人是有查过的？因为老师是书商给的，所以我根本没有去查过这件事。有吗？是买得到的，对吧？是什么？就是天龙书局或什么之类的，是不是可以订得到？是吗？它的出版社是哪一家？我还真不知道。好，反正买得到就好了。OK，suppose you can find this book. You can find and then you can buy this book online. If you have any question buying this book, you can ask me. Maybe I will provide an email for the book company. They also provide me the email. I can forward the email to you, so you can contact him to get this book. Okay, but I need to maybe how to say I need to declare I didn't insist you should buy the book. Oh, okay. So if you want, you just buy it, and if you don't want, you think it is enough. If you only if you only learn from the slide, and then you can don't buy the you don't need to buy the textbook. Okay, that's it. Okay, so continue because why I mentioned about the textbook right here. Uh, Let me check. Okay, because because the book company they provide uh they provide呃教材要怎么讲啊？Okay, they provide me the teaching slide. Okay, the book company they provide me the teaching slide to teach this course. However, it seems like the the teaching slide is the first edition, not the second edition. However, I'm using the second edition. It's what's wrong?你们看到的投影片是正常的吗？各位，我好像把我的多荧幕给弄乱了。哦，反正正常就好了。OK，I don't want waste more time on this. Okay, so uh, if you have a textbook, please focus. This should be page 10, not page 9. Okay, because the the slide is the first edition. Okay. However, I'm using the second edition book. Okay, the abstract data type for neutral number. Neutral number. The ADT neutral number is okay objects an ordered subrange of the integers starting at 0 and ending at the maximum integer. They use it as int max on the computer, and the functions are for all x y belongs to natural number is true or false is a boolean integer, and where plus minus and smaller less than or and equal to are usual integer operations. Okay, the first one is the zero function. Is a natural number is defined as 0, and is 0. It is a boolean. Okay, it's defined as if x return false, else return true. If x is 0, then it will return false, else will return true. Okay. And the third is add x, y. It's a neutral number. If so, the function is if x plus y is less than equal to integer max, the maxima integer, and then it will return x plus y. Otherwise, it will return the integer, the maxima right here, the maxima integer, or equal to here is equal x y. It is a boolean. It's defined it as if x equals to y, then return true, else return false. I think. And then the successor means the next one. Okay. Do you know successor? Hello, everyone. Okay. There is another word is predecessor. Predecessor. How to spell predecessor? Predecessor, right? Cessor. I think it's predecessor. Predecessor means the previous one. And the successor means the next one. Okay. Not sure you have heard this noun or not. Okay, anyway, the successor x is a natural number. It is defined as if x equals to integer max, then return x. Otherwise, it will return the x plus 1, just like I say, which means the next one. And the subtract means minus, right? Okay. If x is smaller than y, then return 0. Otherwise, and it will return x subtract y. It means x subtract minus y. Okay, this is the end neutral number. This is the detail. All these things is the detail of ADT of a neutral number. Right here. Here is the definition. Okay, but just like I say, just like I mentioned before, if you are using ADT, you don't really care about this. You don't know how it does. How it does. You only use it. Yeah. So okay, and here is the algorithm specification. 请教一下，你们看的人会看到我这一个对话框吗？Hello，不会。OK，好，Thank you，Thank you。好，那就没事。OK，啊，挡到你们了。好，the algorithm specification. An algorithm is a finite, uh, finite set of instructions that accomplish a particular task. To for it is a finite set. So sometimes you can see some algorithm. Usually we because my PhD is my I obtained my PhD in CSIE, so of course I have learned algorithm, also the advanced algorithm. So usually we talk about algorithm. We will say an algorithm, an algorithm, especially a good algorithm, should be short and find. So sometimes you will see maybe from paper or from some slide an algorithm. Usually we say it is less than usually. It's just usually, okay? Usually less than maybe 20 or 25 lines. If you see a paper and then he say it is an algorithm, and then you see the maybe to 40 or to 50. I will say that is a pseudocode. And even program. So that's the specification. And here is the criteria. Criteria means criteria, how to say? Criteria means maybe metric. Matrix. Sure. Okay. Criteria. I'm not sure how to. 太难解释了哈。criteria 叫标准或准则。It's a very hard to explain in English. Criteria. Suppose the foreign student can understand what these words mean. Okay. So the first input data should be zero or more quantities that externally supplied, which means I'm not sure other course you have experience or not. Sometimes we will prepare some input data file. Sometimes we will prepare input data file to test your algorithm, to test your program. Okay, the output at least one quantity is produced, and so according to input and output, usually you see a algorithm specification. They will write down like this: input and output, maybe input maybe S, B, Q, maybe A, B, C, something like that. You will put a lot of input data. Input maybe in algorithm. These are variables, and then output maybe output is a result. Maybe you will get a int max, for example, just like a previous example, you will result a maximum integer. Okay. Then the definiteness. Okay. What means definition? Definiteness. Okay. Definiteness clear and ambiguous. Ambiguous means in Chinese, if there is no ambiguous means in Chinese, ambiguous means clear. Okay. Also, finiteness terminate after a fine number of steps. So usually in the algorithm, we will write down the line 1, 2, 3, 4, 5, maybe to just like I say 40 or 50. Usually we will say from line 2 to line maybe 6. It's used to what did you do in line 2 to line 6. So it is finiteness terminate after a number of steps. These are steps. Step 1, step 2. And effectiveness instruction is basic enough to be carried out. Okay. One difference between an algorithm and the program. Okay, here is explaining what is the difference between an algorithm and the program. Is that the later one does not have to satisfy the false condition. The false condition, finiteness. The program does not have to satisfy this criteria or scheduling. Okay. If you are okay, so in algorithm specification, usually in general we will see and maybe and while or and maybe I don't know and something. In the algorithm, you should satisfy the finiteness. But if a program it doesn't need have to satisfy the finiteness criteria. Here's the example. Maybe OS scheduling. OS scheduling is for just like a loop. It's always there is no end. OS scheduling there is no end step in OS scheduling. Okay, so we yeah. Okay, example 1, station sort. Okay, because we are talking about algorithm specification, so here are some sorting algorithms are introduced. The first example is selection sort. The selection sort for those integers are currently unsorted right here, and find the smallest and place it next to the sorted list. Here is the sorted list, so we separate it. Here is sorted, here is unsorted, and then selection sort is we need to check this. Usually we call it element, right? I think suppose you have learned this. Okay. There are a lot of elements. The first part is sorted elements, and the other part is unsorted elements. So we need selection. So we need to find the smallest. For example, maybe 3. Okay, I write down 3. We need to find this and then move it to here, and then to shift this to here. So here is 3, and the sorted is right here. The unsorted is right here. Okay. Here is the I think algorithm pseudocode. I think it's better code this pseudocode. The selection source, the pseudocode is for I equal to 0 and I less than n I plus plus and exam list I. So you use a list to to store the thing. Okay. I think it use a list I to store the this list from here to here. Exam list I to this I. Okay. No. The list I should be here. The list I equals to unsorted, right? I think. Yes. List I list. Suppose it should be list for I equals to 0. I 是这个吧？ Okay, I think not here. I think the list the only because the I is from maybe from E or 2 and 3. From 1, 2, 3. Okay, no matter what. Exam list I to list n minus 1. And suppose that the small integer in the list is list mean. And then you will interchange the list I and the list mean. For example, this is list mean. Then right here is list I. So it interchange these two so that the list mean will follow the sorted list. Okay, this is selection sort. Okay, so here is the I call it algorithm, or I think it's better called pseudocode. It's better called pseudocode, not algorithm. I think not algorithm. Okay, anyway, and here's the real program. So if we want to build a selection sort, and then you must maybe declare a sort function. There are integer list I, a list array, and the integer n. So then for I equals to 0, I less than n minus 1, I plus plus, and then you say the integer mean equals to I. 才是能解释啊。Okay, and then for j equals to I plus 1, j is less than n j plus plus. If the list j is less than j mean, then mean equals to j. After that, then swap the list I and the list mean with the temp. So how to say? I think the textbook is is wants to deliver. Here is the real program if you want to write a selection sort, but the algorithm specification is just like this. Okay, and here is the example. The example is there are input data 20, 10, 15, 6, 17, 30. And in the iteration one, in the first iteration, we will check iteration. In the first iteration, we will check the list, search the list, and find the small list number. And here's the list I, and then exchange them. So here scan from list 0 to list 5. Okay, in the iteration one, it scans from list 0 to list 5. And the smallest number is 6. The smallest number is 6. So it swap 6 with the list 0. Okay, so you can see after that in the iteration one, after swap, the smallest number is in list B. Okay, and 20 is right here. Okay, so the second iteration, the same. Here is sorted list. Here is unsorted list. And then scan the list to find the smallest number. And then you don't need to swap, just like here. You swap to yourself, which means you don't need to swap. Okay, it is a finiteness method. Okay, then you will check here is sorted, here is unsorted. The same, scan the list, unsorted list, find a small list, and swap to yourself, and right here. And suppose this should be scanned and swap with 20, right? In the maybe iteration 3. And okay, that's it. Until the end is all elements have been scanned. Okay. Okay, maybe take a rest. I will back maybe 5 5:15. Yeah. there are two students. Two students knock my door and ask to enroll this course. Uh, mm, okay. Let me speak Chinese a little bit because I need to solve this issue.你们在已经选到课的，在这里面所有的学生应该都已经选到课了。有没有听到外系的就不用讲了哈，外系的基本上本来你加签自己选到的那一种就是那是你的权益这样子，然后或者是双主修辅系的，这也都是必须的，就是必须要给你们选。那有没有那种可能是什么资工系本身的，但到现在还没有注意到或什么？反正刚才有2位学生来就说他们没有看到系办的公告哦，反正就类似像这样。然后人已经多到老师已经快要无感了哦，就是所谓的无感是，对我也不知道到时候考试要怎么考哦，这种100多个人的，我要表达的是，如果你有同学是资工系、资工所，然后要修这门课，但到现在不管是还没选或什么的，反正有另外2位学生也在问，好像他们明天会去问系办啊。那有听得到我声音吧？应该哦，有吗？OK，好，那个你们呃反正有类似这样的状况的，赶快就可能请他赶快去问。呃，反正总而言之，3阶段加选肯定那也没名额了啦，反正好像剩1个名额吧，还是什么的。然后有超过10个以上的外系的想要选这门课或干嘛的，我也搞不太清楚。那反正总而言之就是，呃，有人要去问，那要问就趁现在赶快问，不要到时候又有那种那个什么，这在当兵叫什么？这叫竹笋啊，就是突然冒出1根2根这样子哦，就这真的是很累的。OK，好，没什么，就 OK。can see my slide。哎，OK，thank you，thank you。OK，OK。The second one is second example is binary search, and I think because because they're just a student answer me binary search, so response me and binary search. I think you have learned this, right? Not sure. Okay, have you learned this? 啊，like okay, binary search. Uh, okay, here is the here is the pseudocode of binary search. Binary search means, do you know binary search is divide and conquer? No, I'm not sure. Oh, yeah, not sure. Conquer and yeah. Uh, okay. First, while there are more integers to check, first it will set up a function or variable it's called middle right here, and middle equals to left and right. maybe here, right? 0 and minus 1. Left plus right in the divided root. So here is the middle. So I say binary search is the divide and conquer method. And if the search number is okay, I think let's make before introducing binary search, I think there is a requirement. This is sorted, right? Sorted. So the search number is if the search number is less than the list middle, for example, right here, and the the right is equal to middle minus 1. So you will shift the right here and then check this. Also, and then they will do it again and divide. Okay, and else if the search number is equals to the list middle and then return middle. Very easy. Else if the left is equal to middle plus 1. So you will shift the middle to here. Okay, this is binary search. And here is the binary search. I think it's called program. Okay. So first, there is a integer compare function to compare integer x and the integer y, and it will return -1 for less than or 0 for equal. And binary search, there are integer array list. Left and the right, while left is less than equal to right, the middle just like before, and then we use a switch with 3 cases to compare the list middle with the search number, and the case -1 is while the left is equal to middle plus 1. This kind is you will shift left right here, and the return middle is equals to search number is equals to middle, and then you will return middle. And the last one is you will shift the right to here to middle -1 right here. Okay, this is binary search. Okay, and here is a simple example thing. Just like I said, the binary search is sorted. It already sorted. This is called ascending order. descending order. In Chinese called 生命, okay? Okay. And then you want search for 7. So first, here is maybe 0, 1, 2, 3, 4, 5, 6, 6. And 0 plus 6. So here is the middle. And search for 7. 3 is less than 7. So you will shift the left to here and right? No. You will shift the right to here. Okay, and then check for and do it again. Binary search, and here is the middle, and check the middle. 哦，这里是9吧，很快。I was wrong, okay? The middle should be 9, not 3. Okay, I was wrong. Okay, the middle is 9, and the search number is 7. 7 is less than 9, so yeah, just right here, right to shift right here. And then the middle is 3, and the 3 is less than 7. So the left will shift right here. Okay, and after that, there's no middle. Middle equals to search number, and we just found that. Okay. So comparison between the sequential search and the binary search. Binary search is faster than sequential search. However, binary search requires the input to be sorted in advance, right? Just like I said, you must guarantee the list has been sorted. And the other is, should we always use binary search? Not necessary. So it depends on what kind of problem you need to solve. So just like I said, you need to analyze what kind of problem you should solve. Okay. Okay. The third one is selection problem, and the selection problem it selects the case largest number among n numbers. So there are two approaches. The first approach is the approach one is we read n numbers into an array. So what mean? Here is a array, I give you a array. And there are n numbers. So we put the n numbers into the array and sort the array in a descending or decreasing order. Decreasing order means the large and the small. And maybe from your to 1. Okay. And return the elements in position k because it means case. For example, right here it's k. And return this part. This is the approach 1 right here. And the approach 2 is we can read k elements into an array and sort them in a descending order, decreasing order. Uh, for each remaining elements, read one by one. Then there are n numbers, and we read, for example, the k equals to 3, and we read from the element from 0 to n minus 1. First, we read 0, 1, 2 into the array, and we sort it. We sort it in the decreasing order, maybe just like this, 2, 1, 0. Okay, and we read the third was 0, 1, 2, 4, and minus 1. We read 4 into this array, and then we can see if 4 is bigger than here, and then we push it here and pop this out. So here is for each remaining elements, read one by one. Ignore if it is smaller than the case element. If the 5 element equals to 0, and then we read it in and ignore because it is smaller than 431. Otherwise, place it to the correct place and become one out of array, just like here. Pop it out. So if we focus on data structure, you will consider about we should use queue or we use spec. They are different, right? Because spec needs first in, last out. And the queue is FIFO, first in, first out. Okay, that's it always depends on what kind of problem you are facing. Okay, here is the example. The input data is 30, 14, 9, 6, 22, 31. Okay, maybe we give it a number. Maybe we give it a order. Maybe 0, 1, 2, 3, 4, 5. And then we need to find the third largest number. So we read three numbers every time and sort it then in a descending order. The first we read 13, 30, 14, and then 9, and right here. And we also in a descending order. So 30, 14, 9. And read the next one is 6. And we read 6 and then because 6 is the smallest, 6 is smaller than 30, 14, and 9. So this will be the norm. And read the next 22 right here. And we read 22, and then you can see 22 is small than 30 and larger than 14. So we put 22 right here, and out of push 9 out of list. And also 31. Okay, 31 is the largest right here. And 40 will be out. And right here, okay, 40 will be kicked out. And after that, all numbers are read. And then we can find the third largest number is 22, just right here. Okay, I think this is a simple metric. However, we should consider about this. Which one is better? Um, we use maybe we use selection or binary search. And maybe there are a lot of that. Which one is better? We always there are two ways to think about which one is better. The first one is always consider complexity. We in general we will focus on complexity. Usually we choose a low complexity will be better. And then the other one is the implementation difficulty. Then we consider implementation. Because sometimes it is sometimes we will facing uh, a trade-off issue. An algorithm with low complexity, maybe it is hard to implement. It is difficult to implement. So there's no correct answer. Only because you only focus on what kind of problem you need to solve, and then choose the best solution. And also, okay, efficiency, just right here, time complexity analysis, right here, complexity. Remember that time complexity is not the only yardstick, um, which means you cannot only consider because sometimes I mention it again because it is very important. Sometimes an algorithm it is with low complexity. and which means it is good. Not exactly, because sometimes it is difficult to implement. Or you choose this is the first situation, and then the other one is there is an algorithm with low complexity. However, the low complexity is suitable. It is suitable for the n is big, which means the, the number may be maybe 2 power of 50 times. And if your problem, the n equals to maybe 5, it's very small. You don't need to find a very low complexity algorithm. You can choose a better, maybe a higher complexity, but it is easy to implement. So just like I say here, the space complexity and easy to implement. There are the other two issues you should consider. For example, uh, maybe it need to allocate memory every time, or it is easy to implement. These are some criteria you can choose your data structure. Okay, and then the recursive algorithm. And okay, the recursion, I think. Recursion is usually used to solve a problem in a divide and counter problem, because what is recursion for I equals to, and for say equals to, there are two for loops. So uh, recursion is usually to solve. Again, recursion is usually used to solve a problem in a divide and conquer manner. And there are two kinds of recursion. The first one is direct recursion, and the second one is indirect recursion. The direct inclusion, that functions, they call themselves before they are done. And the indirect recursion functions call other functions that invoke calling function again. So I think it is obviously the direct, and indirect, it will call another, and direct, it will before they are done. Okay. The famous problem is how to say. Let's see. 排列组合要怎么讲？Combination, right? I think C means combination. I think. Anyway, okay, combination. Combination N and M is equals to N fraction. fractional, fractorial. Yeah, I think fractional and divided m fractional and m minus n fractional. So it can be write as this. It's combination n to n. It equals to combination m minus 1 and m minus 1 plus c minus combination m minus 1 and the n. So we should consider the boundary condition for recursion. I think, okay, right here. So if we want to sum e n and it equals to sum 1 and n minus 1 plus n. And here is the other one. And if you sum 1, 1, it equals to 1. Okay, here is the uh, uh, this is recursion summation. I think, have you ever heard this? Fibonacci, how to spell? Fibonacci, spell. Right here? I'm not sure. Have you ever heard this? Fibonacci's I'm not sure how to say. Okay, Fibonacci's. I think more you can understand what I'm talking about. Fibonacci is a very famous recursion method. Okay, and I think there will be recursion sum and the recursion multiply. Yeah, recursion fractional multiplication. The recursion binary search. Okay, yeah, a lot of. Okay, so here is the boundary condition right here. The boundary condition for recursion is the most important. So if n equals to 1 and then return 1, it goes right here, right? And else it will sum n minus 1 and plus n. So you can see here is integer n. So integer n and the sum n minus 1, it is a recursion, right? Also the recursion fractional fact, factorial, okay, factorial. And n factorial equals to n multiplies n minus 1 factorial. So okay, I think I don't need to read this line by line. The most important is the boundary condition for recursion. Okay, the boundary recursion is n multiplies fractional n minus 1. Okay, I think that's it. That's enough. Okay, then the recursion multiplication. See, should I read this? Don't think. We just look the boundary. It's okay. I if okay, and Okay. Boundary binary search. Okay. Let me see where is the boundary. There's no boundary, right? Boundary is right here. Okay. The binary search, we just told it before. Okay, check the left is less than equal to right, and then middle is equal to, okay, I think the most, compare the list middle and the search number. There are three cases. The first one is return middle, and the other two kinds is middle plus y, which means you put the return binary search list search number. Return search left to right. Okay, you put the middle. You put the middle plus one to the left, right? Think the other one is right equals middle minus one, right? Okay, otherwise return. Okay, I'm not sure. Okay, so the most important is we should discuss about the recursion permutation. Yeah, permutation. Permutation. Okay. Permutation. Okay. This okay. Recursion permutation. So if we want to permutation of A, B, C, so here are a few ways. For example, the first one is we keep the first A and the BC to check permutation. Keep B the permutation. Keep C in permutation. Or you can use recursion method. For example, right here, we fix A and the permutation B and C, right? Just like I say, and the fix B and the fix C. If here in the permutation, there is no recursion idea because only because I know this, so I explain like this. So it should be A, B, C, A, C, B, right? A, B, C, A, B, C, and A, C, B, and B, A, C, B, C, A. This is permutation. However, we can use recursion method, maybe A permutation BC. And I just want to say, in this case, there are only A, B, C to permutation. So it is very easy to find out these 6 combinations. It's very easy. However, if there are A, B, C to Z, if you want to use permutation, it's very hard because you need to A, B, C, D, E to Z. and add the to maybe z y. Yeah. It is hard to use permutation when the series when the when the number is very big. However, it's very easy to use recursion method. For example, a the permutation b c, and you can use the you can separate this to this should write z. You can permutation z, and then from d z. Okay. That's it. So it depends on what kind of data structure you want to use, and what's the input data you are facing to solve. I think I think there is no difference between what I say. Okay, I think that's it. Here's the recursion permutation code. Uh, I think that's it. That's enough. I don't need to. Okay. The class is will class is stop here. We will start. We will continue our course next week. And okay, next time I should and Fibonacci. Okay. Uh, please wait a minute. I will ask you to sign up, fill the form. Wait a minute. Okay. Can you see the phone in the chat room? No. Okay. Okay. Please fill the form, and after that you can leave this class. See you next week. Thank you. Goodbye. 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 If you have any question, you can ask me, or you can just leave your message in the Google form. I will read it. Okay. Goodbye, everybody. Bye bye. Goodbye. Goodbye. If you don't have any question or you have done the Google form, you can leave now. I will leave the my brain is stuck, only stuck. Okay. Goodbye. Goodbye. Bye. Goodbye.填完问卷的同学可以离开了。如果你有什么问题，可以留在 Google Form 里面，或者是你也可以在这时候提出来。好的，各位拜拜。没事的，可以来了。老师会看有没有人有什么问题的。 各位不用客气，谢谢各位。